Hello, wonderful humans. Today we are going to talk about domain and range. It's one of the ways that we describe a function. Don't forget to put today's date in here so that you can stay organized. Also, make sure that you check out the warm-up for this activity, investigating graphs, make sure we can read them correctly. Oops. All right, so let's talk about domain. Domain is all the possible input values of a function, also known as our x values. So when we're looking at a graph, we're looking at what are the possible values of x that would live on that function. So over here, I'm looking right across here, and I'm seeing, okay, there's a value x there, and there, and there, and there, and there, right? Living within that section there. The domain lives between the minimum over here on the left, the minimum value, and the maximum over here on the right. So the domain is all the possible x values. Okay, the range is going to be all the possible outputs of a function. What can we get out of the function? Also known as our y values. So when you look at your graph, you're looking at what are the possible y values that could live on that function. So we're looking vertically now. So now we can see we could have a y value here, and here, and here, and here, and here. All these points would have y values. And they all live between the minimum here at the bottom and the maximum here at the top. So domain, input values, also known as x values for the function. Range, output values, also known as y values for the function. Set builder notation is a way that we can talk about domain and range. It's written like an inequality. So we talk about values of x that x might be greater than a certain value or less than a certain value, or less than or equal to. We're going to talk about that. But set builder notation is just a way of describing the set of values that would be the domain or would be the range. Okay, so this is what it's going to look like right here. We are going to look at this right here, and we're going to say, okay, x lives between the maximum value and the minimum value. Now, sometimes the max is like infinity. Infinity isn't a value, it's not a number we can put our finger on, so we don't need that. It's just greater than some minimum. So it doesn't have to have both of these, but both could be there. Notice the difference here between this symbol and this symbol. In the first, we read it as x is less than. In the second, we read it as x is less than or equal to. So in the first situation right here, this value would not be included. Whatever the maximum is, it's just where we go up to, but it's not part of the solution. In the second case, the maximum would be a part of the solution. We can go up and include that point. Same exact thing for range. Again, just how we're writing these things. This should be a review of inequalities, hopefully. Don't forget to do your own definitions, put it in your own words, give yourself an example. All right, so how do we write domain and range? In set builder notation and then also in words. Okay, so set builder notation is going to be with those inequality symbols. So we're going to look at our domain and we're going to see, okay, our minimum is over here on the left. Looks like it's at -2. That's my minimum, my lowest possible value. That means x is going to be greater than, and in this case, or equal to, because of this endpoint. So x will be greater than or equal to. Notice all the values on this little graph exist to the right of that point. So all values will be greater than. And also, it's going to be less than or equal to, again, because this is a closed endpoint. It's going to be less than this maximum value of 3, less than or equal to the maximum of 3. And this is how we write in set builder notation the domain of this graph on the left here. In words, you're just going to say that x is less than or equal to 3, and it's also greater than or equal to -2. Okay, so that's how we're going to say this in words. Let's look at the range. Now we're looking at our max and min height, the highest and the lowest values. So right here, I know my maximum height is right there at 2, and my minimum height is right here, looks to be at -1. So y has to be above or greater than that -1 value, and below or less than that 2 value. So y lives in the middle. It's less than or equal to, again, because those endpoints are closed. They're part of the solution. It is less than 2. It is greater than or equal to -1. Okay, so how would I say that in words? I would say that y is less than or equal to 2 and greater than or equal to 1. Less than or equal to 2 and greater than or equal to 1. Make sure you're writing these down. Lots of practice. Okay, what if we're given ordered pairs or points, inputs and outputs, right? So our inputs are our x values, also known as domain. And our outputs are our y values, also known as our range. In this case, we're just going to list them out because we don't know if the values in between these points are included or not. All we're given are the points. So the domain is going to be -3, -1, 1, and 3. Those would be the points that satisfy our domain. In words, the domain includes -3, -1, 1, and 3. So we're just putting this into words so that our brains can understand what we're talking about here. All right, so what about the range now? What about the range now? I'm picking all different colors here, this problem. Okay, what's the range going to be? The range is going to be our output. So in this case, -2, 0, 2, 4. These are our output values. Again, in words, you're just going to say the range includes -2, 0, 2, and 4. We don't know if there's anything else, but from the given information, that's what we know. All right, same idea from a table, because really what we have here is an ordered pair, right? So here we have our x value and our y value. So the table is going to be just like the previous example. So our, let's use a different color. Our input values are going to be our domain. So it would be 2, 4, and 6 in words. The domain is 2, 4, and 6. The input values, that's all we know. Okay, what about our output values over here? Let's look at our output values. Our output values, or our range, 2.6, 5.2, and 7.8. Again, in words, write it out the way you would say it to me. Okay, now I want you to identify what is the given information. So what are we given here? Well, we're given a graph. So the domain from a graph, also going to be the range from a graph in set builder notation. Okay, so we're going to look at the farthest value to the left, -4. And I notice on the right, when I'm looking for my farthest value to the right, I have an arrow. That means it's going to go and go and go and go and go forever and ever and ever. So to infinity and beyond, right? So that means that our x values have to just be greater than or equal to, because that endpoint is filled in, it's included, this minimum value of -4. Then it just keeps going. It can be anything greater than -4. All right, in words, x is greater than or equal to -4. Okay, let's look at our range now. Okay, so now we're looking at our maximum and minimum heights. Well, okay, so the maximum, this arrow tells me it's going to keep going and going and going up and up and up and up, so it doesn't have a maximum. And the minimum is going to be found at the lowest part of the graph, the smallest value of y that I can find on that graph. So if you look right here, this looks like -3. That's the lowest value of y that exists on this function. So y must be greater than or equal to -3. Now notice over here I wrote the x on the right-hand side, and over here I wrote the y on the left-hand side. It really doesn't matter. You can write them either way. They mean the same thing. Just again, remember that we're going to read from our exponent. So when I read this or write it in words, I say x is greater than -4. So I focus on the values that are true for that. When I read this one, y is greater than or equal to -3. Again, we're focusing on what values are we looking for here. Okay, keep going. Still from a graph. From a graph. Okay, so now my domain. Okay, I want to highlight a key feature here. Notice this is an open circle. So that means that while this graph approaches that x value of 3, it does not include 3. 3 is not a part of the solution. So this is our first example where we're going to write x, and then it's going to be less than but not equal to the highest value of 3. It's going to be greater than or equal to -2, and that is going to be our domain for this graph. All right, let's think about y here. Let's switch over. Y, now we have a maximum here of 4 and a minimum down here at -5. And my minimum is the value that is not included. So -5 is my lowest value. Y must be greater than that. It cannot be -5. It can't actually get that low. That is a value it approaches but cannot touch. So it's not allowed to actually be -5. And then it's less than or equal to this maximum value up here of 4. That is included because that parabola touches the y value of 4. Okay, make sure you're putting that in your own words as well. Okay, again, we're going to do domain from a graph. Okay, this is going to have a minimum. Ooh, let's change that color. Let's do our domain in purple. Okay, so this is going to have a minimum of 0 and a maximum of 6. X is less than or equal to 6 and greater than or equal to 0. Again, looking at the farthest point to the left, farthest point to the right, put that in your own words. All right, then for my range, now I'm looking at my highest value and my lowest value when I'm talking about y, or my vertical values. Okay, look, it's the same. Y is less than or equal to 6 and greater than or equal to 0, but I'm looking in different locations. So even though they happen to be the same, we are looking at different information. So this is for my x, my domain, and this is for my y, my range. Make sure you're putting this in words. Okay, this is the you try section. You want to pause the video and check these out on your own. Do your very best. Okay, so on number 7, we're given a table. So this is from a table. And because I've been doing range in green, I'm going to go here first. Okay, so what are my y values? What are my output values? 3, 11, 9, 27, and 35. We're just going to list these out because we don't know if there are any other values included. We just know the given values. We don't know if this is a connected line or what this represents, but we do know those values are part of the range. All right, what about the domain or the input values here? Again, it's a table. We're just going to list them out. 0, 2, 4, 6, 8. Again, make sure you're putting these in your own words so that you're connecting that idea. Okay, number 8, we have domain from points. Okay, what's my domain? Well, that's going to be all of my x values just listed out. -2, -1, 0, 1, 2. Again, write that in words. Okay, my range is going to be 0, 1, 1, 2, 2. Do you think I need to write those 1s and 2s repeatedly? Because I see those numbers repeating a lot, and I don't really think that's necessary. So if 1 is a part of the range, then 1's a part of the range. I don't need to write it twice. So really, we could just write it as 1 or 0, 1, and 2. Those are the points that represent the range. If you write them out extra just as you're thinking about it, it's fine, but just cross them out. They're not necessary. Okay, let's look at from a graph. Let's look at the range first. Minimum value looks like 0 there. Maximum value is 4, and it's included because those endpoints are filled in. So y is less than or equal to 4 and greater than or equal to 0. Okay, let's look at the domain. Now we're talking about farthest value to the left, farthest value to the right. That's going to be from these points here. Farthest value to the left is 1, included because of the closed circles there. So 1 is my minimum value over here. 5 is my maximum value over here. All the x values, all the input values reside within those two values in the middle here. Okay. Domain from a graph again. Now we have to actually count because the numbers are not given. 1, 2, 3, 4. 4 is my max. 1, 2, 3, 4. Negative 4 is my min. X is greater than or equal to negative 4 and less than or equal to positive 4. Okay, range. My maximum value up here, minimum value up here. Again, we're going to count 1, 2, 3, and 4. Y is less than or equal to positive 4 and greater than or equal to negative 4. Circles are symmetrical, so once you know the center point there, they should be symmetrical about that. So that's why sometimes circles end up having the same domain and range listed. Okay, this is domain from a graph, but in this case, notice these points are not connected. So because these points are not connected, we're just going to list out the x values. So I see an x value of 0 right here. Oops, let's do this in pink. An x value of 0 right here connecting to this 0.08. So that's a 0, 1, 2, 3, 4, 5, 6, 7, 8, and notice this 7 actually exists twice, but I only need to list it once, 8 and 9. And those are all the points that I can see from this graph. I'm going to clear this off so we can look at the range. Okay, now when I'm talking about range, I am talking about my y values, of course, my output. So now I'm going to look here and see that this is at 8. So 8 is an output. Notice these are also at 8. Don't need to repeat those. I also have 9. I'm kind of working backward here. I'm going to put my max 9, 8. Okay, and then don't have any points at 7. Here's a 6. Lots of 5s. Only going to write them once though. Oops. Okay. And then 4, we have 2 different 4s. Again, only going to write it once. And then nothing at 3, and then 2 at 2. So because these values repeated for my range, I'm only writing them once because those are the possible values of y. We're not specifically saying where they exist. All right, let's look at the domain of this graph here. Actually, let's do range first because I'm in green. So range, our maximum is here at 3. Our minimum is at 4. So y is less than or equal to 3 and greater than or equal to 4. Our range or domain, looking left to right, we're going from negative 3 at the minimum. X is greater than or equal to negative 3 and less than or equal to 3 at the maximum. Okay, getting closer here. All right, we're going to assume this is an endpoint here because I don't see an arrow there. And since I do see an arrow on the other side, I'm just going to assume it ends there. So this is from a graph. And this is going to be x is greater than or equal to 0 because my minimum value over here is 0. And this thing is just going to keep going and going and going and going. All right, let's talk range. My minimum is right here. And my max is going to keep going and going and going and going up. So y has to be greater than or equal to 1. And it doesn't matter how you write this. You could also write 1 is less than or equal to y. And over here, we could write x is greater than or equal to 0. Those are exactly the same. Order doesn't matter for that. Okay, hopefully you can process that. You practice these UTI problems. Hopefully you're putting them in your words. And yeah. We'll see you next time.